We'd like to differentiate this function. We see that we have a quotient, so we're going to use the quotient rule, and we're going to take the bottom, 1 plus tangent x, times the derivative of the top. The derivative of secant x is secant x tangent x, minus the top, which is secant x, times the derivative of the bottom. Derivative of 1 is 0. Derivative of tangent x is secant squared x. And that's all over the bottom squared, 1 plus tangent x squared. So that's our quotient rule. Now let's go ahead and get rid of those parentheses in the numerator and see if there's anything we can do to simplify. So we're distributing the secant x tangent x. We got secant x tangent x plus secant x tangent squared x minus secant cubed x, all over 1 plus tangent x squared. Now it may depend on what we want to do with this derivative, of what kind of form we might want to use it in, or how much we need to try and simplify. So what we're interested in here is for what values of x does the graph have a horizontal tangent. So we are interested in finding out when this derivative equals 0. So let's go ahead and factor a secant x out. We see it's in all three terms in the numerator. So we've got secant x multiplied by tangent x plus tangent squared x minus secant squared x equals 0, and over 1 plus tangent x quantity squared. Now we can use a Pythagorean identity here because we know secant squared equals 1 plus tangent squared x, and we could replace this secant squared with that so that we could do some further simplifying, since our other terms are tangents. And we have tangent x plus tangent squared x minus 1 minus tangent squared x, since that negative applies to both terms there. We're interested in where that equals 0, because if the numerator of the fraction equals 0 and the denominator doesn't equal 0 there, then we know we have the fraction equaling 0. So the only place there's going to be an issue with the denominator equaling 0 is when the tangent is -1. So that would be at 3 pi fourths. We would have an issue with that, and so we just need to make sure we're not using those same values and then multiples of pi added to that. Alright, so let's see, our tangent squareds would cancel. I've left the x off right here, and looks like if we want to figure out then where this numerator equals 0, it's either where the secant x equals 0 or where tangent x minus 1 equals 0, just simply setting each factor equal to 0. Well, we know secant x is 1 over cosine, and where does that equal 0? And that never does, because if we've got 1 in the numerator, we'll never get this fraction to equal 0. So let's look at our second piece. We're interested in where the tangent x equals 1. Now the only time we'd have troubles with the denominator being 0 is if tangent x equals -1. So we won't have any problems there, and let's figure out the values where tangent equals 1. Well, that's going to be at pi over 4, where the sine equals the cosine, and at other multiples of pi, so we'll say plus n pi. And at these particular x values, we will have the slope of the tangent to the curve equaling 0. So essentially that means at x equal pi over 4 or plus or minus multiples of pi, that we will have horizontal tangent. Now let's go ahead and look at the graph so that we can see that. And here we have our horizontal tangent at pi over 4, and then we have another one at 5 pi over 4. We have one over here at -3 pi over 4, and of course if we continued this graph, this would continue at every pi over 4 plus any multiple of pi.